Alright, so this will be our second and final notes of the first week. Most weeks just have one lesson, but we have a couple with two. It's always better to do it earlier in the week. I would aim for Mondays and Tuesdays, Wednesdays at the latest. Try to get your stuff done in advance. Let's flip this around and get things done early. So Taylor and Maclaurin polynomials are an important topic, usually always on the AP exam. Maclaurin is a special situation when c equals 0, and it reminds me, I kind of wrote it down here, it kind of reminds me of Rolle's theorem, how Rolle's theorem is a special case of the mean value theorem when the value equals 0. So similar to that, where they're basically the same thing, these are basically the same thing. This is just a special case of a Taylor polynomial. Okay? So all functions can be approximated using a polynomial. It won't be the same value, but at times it'll be so close it won't really matter. I'm just reading this to you, so that probably shouldn't be necessary. So if we compare the function e to the x to these three polynomials, and if we plug in 0, well, this one, all of these turn out to be 1. So that's exact. If we look at 1, so e to the first power is 2.71828. Now in calculus we round things off to the thousandths place, so we would just stop there, but it's 2.1828459045. But that's so if we plug 1 in here, 1 plus 1 is 2. And if we plug 1 in here to this polynomial, and you can type that in your calculator to verify this if you want to, but that would be 2.6 repeating, and this one here would be 2.7167, and out to 3 decimal places, that's pretty close. And if we move over and do e squared, that's going to be 7.3891, etc., and that would round off to 7.389. So we want to keep that in mind. If we plug in 2 here, 1 plus 2 is 3. That's not very good. But if we extend it out to a couple more terms, then that would be 6.3, which is still 6.3 repeating, which is still not very good. And if we go out one more, or 2 more actually, 7.26, and depending on what you're doing, that might be, so to round this up, that would actually be 7.267. We want to focus on that. So okay, so that's what we're going to focus on. We're going to focus on how do we come up with a Taylor polynomial or a Maclaurin polynomial, because later on in section 8.10 we're going to do some things with those. So looks kind of complicated. Here's the basic formula for Taylor and Maclaurin polynomial. Probably should have an S on there, huh? Okay. So we're going to take the function at the value and then divide it by, they left it off here because it's equal to 1. 0 factorial is defined as 1, and 1 factorial is 1. But technically, if you want to establish the pattern, it might be good to have those on there. So that would be the Taylor series for the function at c, because we would be plugging that number in for c. So, and then here it says if c is 0, then it's called a Maclaurin series. So, and it's just a special form of that, which I said here. So, all right. So let's see what we would have to do with this. Now, this is number 6 from our examples in our textbook. So when you're doing your assignment, this kind of gives you an idea of matching them up to help you. This example should help you with those early problems in the section. So what we can do is just start with the first, so if we use k here and say that k is equal to 0, and then we take k as the derivative of the function here. Okay. So this would just be the function itself because k would be 0. So the 0 derivative, which would just be the function back. So I'm going to rewrite that as 4x to the negative 1/3. Okay. And then what we're doing here is basically looking at the first term here. So now we're going to evaluate the function at c. So for us, that's going to be evaluating that at 8. So if we go back, that's 4 over the cube root of 8, which is going to be 4 over 2, which is 2. All right. And then our last step there would be to take that at c and divide it by k factorial. So in this case, that would be 0 factorial, which would be 1. So we would have 2 over 0 factorial, which is 2. So that's the first term of our Taylor series. All right. So now if we plug in and look at 1, we're looking at the first derivative of this. So if we take the derivative of this and bring that down, bring the exponent down, multiply, so that's negative 4/3, and subtract 1 from the exponent, that's going to be negative 4/3. Okay? I guess I could have used a different color there to kind of keep track a little bit differently. So that's going to be negative 4/3, and then this is going to be 1 over the cube root of 8 to the 4th power. So the cube root of 8 is 2, 2 to the 4th power is 16, and that was negative, so it drops it down, so it's 1/16. So that's going to be negative 1/12, if you look at that. And then here we have negative 1/12 divided by 1 factorial, which is still going to be negative 1/12. Okay? And so we can, and it said find P1, so that's what we're doing here. So the first Taylor polynomial. So the first term is 2, and the second term is f prime of c, which we just found over here is negative 1/12. So that's going to be minus 1/12 times x minus c, and c was 8. Okay, and that would be it right there. Now maybe we should do a little bit of work on that. So if we distribute that, that would be 2 minus 1/12 x plus 2/3. So actually polynomial will be 2, just kidding, 8/3. This will be 6/3. So let me clean that up a little bit. And they're writing those in reverse order. I suppose I could leave it in reverse order. So that would be 8/3 minus 1/12 x. Maybe we'll go with that one. So this part right here, you could do that a little bit differently, possibly if you wanted to, but I'm just going to do this one the same way. So this time it's asked for Maclaurin, so that means it's going to be 0, so it's going to just be x in here, so that's okay. So degree 5, though, that means we got to do quite a few of them. So we're going to go 0, and then we have that of x, and so that's going to be just the function, which is e to the negative x. And then we need to evaluate that at 0. So e to the 0 is going to be 1. And then the next step is to take that, evaluate it at 0, because that's our center, and divide that by k factorial. So that's just 1 divided by 0 factorial. So that's just going to be 1. Okay? Now, if we go to the first derivative, we need to take the derivative of this. So if we take the derivative of this, that's going to be negative e to the negative x. Remember, the derivative of e to the u is e to the u times du. So the derivative of that's negative 1. So there we go. And if we plug 0 in there, we're going to get negative 1. And we'll have negative 1 divided by 1 factorial. So that's going to be negative 1. Okay. And moving on to 2. So when it tells you of degree 5 or degree 1, that tells you that, then that tells you how far you're going to go here to that number. So we had a 1 here because that 1 matches up with that 1. We could highlight that if we want, maybe. And here we're going for a 5. So, all right. So now if we take the derivative of this, that's going to be e to the negative x, because we're going to take the derivative of that and then bring down the negative 1, and that'll be positive. And so if we plug in 0 to that, that's going to be a positive 1. We're going to have 1 divided by 2 factorial. 2 factorial is 2 times 1, 1 times 2, so that's 2, so that's going to be 1/2. Okay, and this is possibly going to get a little tedious here, so hopefully we're just going to see the pattern. I guess I'll just keep doing it because it's our notes, and maybe we would like to have those complete. So now we're going to have negative 1 divided by 3 factorial, so that's going to be negative 1/6. And then back up, well, not back up, but now I'm switching back to blue. But derivative again. So these are just alternating, so that should not be much of a problem. And so here we need to multiply that by 4, because that's 3 factorial, so 4 times 4. So that's going to be 1/24. And then we just have 1 left here, so that's going to be the 5, which I was going to highlight before, but so this is going to be here, and negative 1, and negative 1 divided by 5 factorial. So that's going to be that times 5, which is 120. And now we have all of the pieces that we need, kind of the coefficients there. So let's go P5 of x, and that's going to be 1. And then you have to remember this part right here. Now c is 0, so this is x. So the next one is going to be negative x, and then plus 1/2 x squared, and then minus 1/6 x cubed, and then plus 1/24 x to the 4th, and finally 1/120 x to the 5th. Okay. So there we go. Alright, so that's at degree 5, that's why we went to 5, and that's why we have 5 there. So we could set that up here again, and this time it says 3rd degree, so we're going to go up to 3, so 0. So that's just the function itself, so that's going to be tangent. And the tangent of 0 is 0. Just kidding. 0. And 0 divided by 0 factorial is 0. Okay. So if we move on to the first derivative, so here's a good practice. You can pause the video and fill in these things one step at a time, and then play and make sure I match. The derivative of tangent is secant squared, and that's 1 over cosine squared, and we plug 0 in there. Cosine squared of 0, or cosine of 0 squared is 1, so that's 1 over 1, so that'll be 1. We have 1 divided by 1 factorial, so that will be 1 also. Alright, now we go to the second derivative. So that's a little bit trickier here, so we have to use the chain rule. So we're going to bring the 2 down, and we'll have 2 secant x times the derivative of secant. But the derivative of secant is secant tangent. So that's going to give us secant squared tangent. Alright, and if we evaluate that at 0, the 0 at tangent is going to cause that to be 0 times 1, so that's going to be 0. And then 0 divided by 2 factorial is 0. Okay, and finally the third derivative. So the third derivative here, let's see, this is the product rule, so that just got a little trickier on us. So this is going to be the derivative of this, which is going to be 4 secant x times the derivative, we're going to use the chain rule, times the derivative of secant, which is secant tangent. Alright, so one more time, I just wanted to pause for a second. So this is a little bit tricky. So we have the product rule here. So it's the derivative of the first thing times the second thing. So the derivative of this is going to be 4 secant x using the chain rule times secant tangent. So that's going to give us secant squared again. And then that's going to give us that extra tangent, but then we have to multiply it by this also. So that's going to be tangent squared. Plus the plus this times the derivative of that. So the derivative of tangent is secant squared. So we're going to have 2 secant squared times secant squared. So that's going to be secant to the 4th. Okay, so if we evaluate that at 0, then this is going to be 0 plus, and this is going to be 2 times 1. So that's going to be 2. So we're going to have 2 over 3 factorial, which is 6. So that's going to be 1/3. Okay, and so now we can write out the polynomial. So this is 3 and here. So I guess we would start off with 0, and then we would add, and so that's the constant, and as you move across that would be x, so that's going to be x, and then plus 0x squared, and then plus 1/3 x cubed. So if we break that down, get rid of those zeros because that looks a little awkward, we're just going to have this. Okay, and that's an odd, so you could check it in the back of the book, make sure that's we're good on that. Okay, and let's do another one here. We have 3 left. So here we have a Taylor. Oh, yeah, that was a Maclaurin, so that's why it would be x minus 0, parentheses. Okay, so here we go. This one, Alright, so set up your table, same as the last 3 problems before this. Plug in 2. Plug in a 2. So that would be 2 over 2 squared, which is 4, so that's going to be 1/2. So we're going to have 1/2 divided by 0 factorial, so that's just going to be 1/2. Alright, and then if we move on to 1, that's going to be the first derivative. So we take the derivative of that, that's going to be negative 4x to the negative 3. And then if we plug 2 in there, that's going to be negative 4 over 8. Negative 4 over 8. So that's going to be negative 1/2. And this is going to be negative 1/2 divided by 1 factorial, which is just negative 1/2. So, moving right along, 2. So, I mean, it's not a big deal. You just have to memorize how to set it up, and then you just, it's kind of, you know, plug and chug, grind it out. So 2 to the 4th is going to be 16. So that's going to be 12 over 16, which is going to be 3/4. And over here we're going to have 3/4 divided by 2 factorial, which is just 2. So that's like times 1/2. So that's 3/8. Okay. And 2 more. So 3, so that's negative 48, x to the negative 5th. And if you plug a 2 in there, that's going to be negative 48, and 2 to the 5th is 32. So 8 goes into there, actually 16. So that would be 3/2, negative 3/2. Okay, so we have negative 3/2 divided by 3 factorial, which is 1/6. So that's negative 3/12 or negative 1/4. However you want to break that down. And then the last step on this one is the 4. So that is going to be 240 x to the negative 6th. So that's going to be 240 over, 64. So that would be 30 over 8. 8 goes into both of those. 30 over 8, and then 15 over 4. You don't have to do that in your head. You can do it on the side or whatever, whatever works for you. So this is going to be 4. So that's going to be, that's 6, 4, 24. So that's going to be 1 over 24 times 1 over 24. So 3 goes into there 5 times, and 3 goes into there 8 times. So that's 5 over 32. Okay, so if we do our 4th degree Taylor polynomial, and we start with our first term, that was 1/2. And then our next term is negative 1/2, and now we have to start putting in the x. And because it's a Taylor polynomial, we don't have 0, we have 2. It's going to be x minus 2. I'm not going to simplify this out. That's a bit tedious, and they wouldn't have us do that for this long thing, I don't think. So our next one is positive 3/8, and that's going to be x minus 2 squared, and then minus 1/4. That's going to be x minus 2 cubed. And then our last one there is going to be 5/32, x minus 2 to the 4th. Okay, so almost done. Alright, so I'm going to change this a little bit maybe. So if we realize that the function itself is e to the x, but the thing about that is that the derivative is e to the x. Okay, so that's a little bit awkward. So that's just going to be e to the x, and that's going to be e to the x, and etc. Okay, and if we plug in 1, we're going to have e to the first power. So that's going to be, so for that next one, that's going to be e and e and e. So those are all going to be e. I mean, you still could do the chart if you wanted to. That's going to be k, and that'll be that. And then this will be at 1, f of k at 1. And this is f of k at x. Squeeze that in there. And then you could get the coefficients over here. But if we think about that, so the 4th degree Taylor, because it's not equal to 0. So our first, so one more thing would be divided by k factorial. So those are our 4 things in the chart. But so this is going to be e. So that first thing is going to be e. Okay, and then the next thing is going to be e also. And that's going to be x minus 1. And then the next thing is going to be e, because they're all going to be e. So that's going to be x minus 1 squared. except that's where the k dividing by k factorial. So we got to remember to bring in the 2 factorial, and I don't know if I want to leave that. So 2 factorial is just 2. I guess I'll just do it that way. And then, okay, we had to go 4. So it's going to be x minus 1 cubed, and then 3 factorial is going to be 6, and then the fourth one is going to be x minus 1 to the 4th, and that's over 4 factorial, so this was times 3, that'll be times 4, so that's 24. Okay. Alright, and last one, we're going to do the first, second, third degree Maclaurin polynomial, and then we're going to talk about the general form for any. So let's do them one at a time. So we have the function is going to be e to the x. And if we evaluate that, because it's Maclaurin, it's 0. So if we evaluate that at 0, we have e to the 0, which is 1. So our first degree polynomial let's just disregard that. This is the 0, remember? That's the 0. And then the first one is actually when we take the derivative. So we would have the derivative of this, which is just e to the x, and that's f prime of 0 equals 1. So this is going to be our first one here. That would have been p of 0, which we don't really need. So p of 1 is going to be 1 from here plus 1 x, or just x. Okay? And now if we go to the next one, that's going to be, so that's the first one there. Here's the second one, so that's the second derivative. The derivative of e to the x is just e to the x. So the second derivative of 0 is also 1. So this one is going to be 1 plus x. Now here's where you have to remember, we're to the second one, that's where we have to start dividing by those k factorials. I mean, technically we have to do that here as well, but they're both 1, so it's not really a big deal. So here I'm going to leave it as a factorial though, because we want to, the general term is a pattern, so we want to see the pattern, so it'll be easier to see the pattern if we leave the factorial there. Okay, so the third one. So again, this is pretty tedious, they're all the same. So this is e to the x, third derivative at 0 is also 1, and so the third degree polynomial is going to be 1 plus x squared over 2 factorial, and then x cubed and 3 factorial. Okay, so this, the Maclaurin, we want to memorize that. So you want to start to memorize that. So remember the polynomial for e to the x, it's just all the terms. And you just start with 1, it's 1x, x squared over 2 factorial, x cubed over 3 factorial, x to the 4th over 4 factorial. So e is all the terms in order. It's pretty straightforward. Okay. So the general, we're almost done. Last thing here, the general term, any term. And I think they ask a question on the AP test, what would the certain term be? So it's the general formula n to infinity of x to the n over n factorial. So if you think about this, if we plug 0 in here, we get 1 over 1, which is 1. If we plug 1 in here, we get x over 1, which is x. If we plug 2 in here, we get x squared over 2 factorial. And so it gives us, this is the formula for that pattern. So that hopefully will be easy to memorize. So let's try to keep up and stay ahead. And let's get our work done this week. Only three assignments and only 2 notes. So nice way to ease ourselves back into it. It's about that time.